In the last of these polymer videos, we're going to have a look at hydrolysis of polymers. Now, in carboxylic acids and esters, you will have looked at hydrolysis of esters and amides already, so this is just an extension of that. So one of the things we're going to look at, we've already briefly mentioned, is that addition polymers do not undergo any kind of hydrolysis, any kind of breaking down, just because we've got carbon-carbon single bonds. Yes, they're chemically inert. The backbone is non-polar. No polar bonds in the backbone. Yep. So they cannot be hydrolyzed. So if you were to dump your addition polymers at the tip, they would just stay there indefinitely. Condensation polymers, on the other hand, can be hydrolyzed. And remember that hydrolysis is the breaking of bonds using water. So if you leave these on the tip, it will break down eventually. It's very slow, so you can add a catalyst. And in chemistry, we would do that in the lab. We would add a catalyst, either aqueous strong acid or aqueous strong base. Now don't be confused by that. Aqueous doesn't mean the same as strong. Strong means fully dissociated, releases its H's, H plus ions. Aqueous means dissolved in water. So concentrated would mean lots of hydrochloric acid and not much water, and dilute would mean lots of water and not much hydrochloric acid, both of those being having some water. Strong or weak is about the level of dissociation, so you just need to be careful with the use of words in chemistry. So here we've got a polyester. We can spot our ester bonds. I'm going to draw a squiggly line through them like I have been doing. I'm going to put the squiggly lines at the end. Remember, the two trailing bonds are always ester bonds, and then find the C double bond O to O in the middle. They're my ester bonds. And if I were to use let's put the acid on this side, just the one that's first. Aqueous acid or aqueous alkali. What sort of products would I get? Now, if you're struggling with this section, you want to go back and review hydrolysis from earlier packs. So if I hydrolyse those bonds, the first thing I've got to do is think, well, I'm just going to break up those bits, and I can almost in my head think about the monomers that I would have got back. So I can sort of pencil that in. It's not going to necessarily be the right answer, so just be careful. I'm just going to pencil that in. I might need to change it, so maybe use, don't put it in pen. So like, get the monomers back, just like we have been doing. Okay. And then I need to think to myself is, would either of these monomers react with hydrochloric acid? Do alcohols react with acids? Do carboxylic acids react with acids? Well, neither of these two functional groups react with hydrochloric acid, so that is the products. We're going to have a diol and a dicarboxylic acid. Now, if I do the same thing, these would be the same monomers, so I've got them there. And just to think to myself, if I was using NaOH, would either of those react? Well, alcohols don't react with NaOH either, so that would still be there as a diol. But carboxylic acids react with alkalis to make salts, so I'm going to end up with the salt, which is where I'd have the Na+, and that hydrogen ion of the Cu group has come off. Double bond O, and we've got a zigzag like that. 1, 2, 3, 4. And the same at the other side, and we've got another Na+. So that is now not a dicarboxylic acid anymore. That would be a dicarboxylate salt. So with the alkali, we're going to form a salt. Again, you have covered this in other packs, so go back and have a look in your carboxylic acids pack, and you will see that you've done this before. If we do the same to polyamides again, find the amide bond, so where the C double bond O joins to the N and the two trailing bonds. Again, pencil in what you think the structures might be under the two different types of conditions in a lab. I'm going to pencil them in. They're not necessarily going to be the right answers. I'm going to have another think again, so that's just thinking about the monomers. That's my diamine there, and then a double bond O. Double bond O. It was just two, wasn't it? So then we have that. So there's my two structures. Now, do either of those react with hydrochloric acid? Now, if you remember from your amines notes, you'll see that amines are bases, so they react with hydrochloric acid. So actually this structure here isn't quite correct. I need to add a third hydrogen to each of these ends and put a plus on it. So I'm going to make a diamino salt. So that one's called a diammonium, like an ammonium ion salt, and this is a dicarboxylic acid. Acids don't react with other acids like this. This is a dicarboxylic acid. So the HCl has reacted with the amines. So again we think, what would the monomers have looked like? Just pencil those in to start off with. And then what would the other monomer have looked like? So these are my two monomers. Do either of those react with an alkali? And amines don't react with alkali, so I've got a diamine here, because it is a base itself, so it doesn't react with another base, but the acid will. So I'm going to lose the protons off the acid and make a dicarboxylate salt. Okay, so if you struggled with that, you need to go back and look at hydrolysis of amides and esters in the carboxylic acids pack. Also make sure you understand the reactions of acids with bases, and that has come all throughout chemistry. That's the end of this little video on hydrolysis.